Okay, so we're going to try our third inductive proof now, and just like the previous two, it's going to fall into two steps. The first step is showing the base case holds true for our core, and so our core here is showing, using induction, that 3 is evenly divisible, that 7n plus 2 is evenly divisible by 3. And we start off by doing that by looking at our base case, which is just saying, does this hold true for n equals 1? In this particular instance, so we can rewrite this 3, 7 to the power of 1 plus 2. 7 to the power of 1 is 7 plus 2 is 9. 3 evenly divides into 9, therefore our base case holds true. Now we need to move on to our inductive step. And as with the previous two examples, all we need to show is that this same statement holds true for n plus 1. So we're going to start off by just directly substituting that into the formula, and then we need to show that it will also be divisible by 3. So 7 to the power of n plus 1 plus 2. Now we've done this twice before, but this is quite a different example because now our n is up in the power, and so we're going to have to use some power rules to get around this. And the easiest way is to realize that 7 to the power of n plus 1 is the same as writing 7n times 7 plus 2. Right? Now, that really doesn't help us too much at all either, because we can't simplify this out. We can't easily get from here back to there, and then by showing this is true, infer that that is true. What we can do, though, is realize that another way of saying that we assume this is true is saying that for some integer m, we can write that 3 times m is equal to 7 to the power of n plus 2. If this is true, then this must also be true. And n can be any integer, right? And what we can do, we can rearrange this now to solve for 7n. Doing that, we're going to get 3m minus 2. And now we can see, we can replace the 7n in here with this expression. Yes, it does look like this is making it more complicated, but it will very quickly simplify out into something that's obviously divisible by 3, which is why we're doing it like this. So writing it explicitly, we've now got 7 times 3m minus 2 plus 2. If you figure that out, you're going to get 21m minus 12. And what we can see here is that both 21 and 12 are divisible by 3. So we can pull 3 out as a common factor, and we're going to get 7m minus 2. And because whatever we put in here is going to be multiplied by 3, therefore our resultant is going to also be divisible by 3. So this is the end of our inductive proof. We've shown that everything in here will be divisible by 3.